All right, Brian, we heard you're on vacation. Hopefully you're having fun. But your homework is 5.2 worksheet. Yeah, we're not on Schoology yet, so I guess you'll either have to hope that Caleb brings you one, or I don't know, come
or
visit.
David.
Or David. But we don't even know where he is.
Cedar Point, probably.
Oh yeah, he talked about going to Cedar
went
Point.
there.
No, he's talked I was talking on the bus and he said, I'm not sure if it was today, but he said he was gonna miss the day to go to Cedar Point.
So on the chapter 1 test, I know chapter 2 is on the board, but were there any big go to the group questions on chapter 1? Was that the G or the K?
G.
The G. So any big questions from chapter 1? Yeah.
What are converse, inverse, and contrapositive?
Yeah, I know that.
It's actually easier.
I'll look it up.
I'm just going to search that
I
up.
know that.
I miss you, Brian.
It's like when you change the sentence in or the statement, and you either reverse it or put a not before it.
This is the easiest way to, that's a really
And
bad,
put a not before it.
if this loads up well. So your statement, your original statement says if P, then Q. So like if it's raining, we'll get wet. A statement like that, right? And this is not loading quickly enough. Here we go. So the converse is if Q, then P. It flips around the P and the Q. So converse flips around. So if I got wet, it must be raining. Well, that might be true, but not always. The inverse is saying if not P, then not Q. So if it's not raining, then I won't get wet. Well, that's probably sometimes true, but if I went to the pool, it could not be raining and I could get wet, so that wouldn't always be true. And then if not Q, not P. So if I did not get wet, it is not raining. Well, no, I could just be inside. So your first is your conditional, then converse, inverse, and contrapositive. So converse, think of con as just flipping them. Inverse is invert both of them in the same order, P then Q. And then contrapositive is flip and invert, not Q, not P. Other questions from the chapter 1? Yeah. And I actually can't find the file that quickly, so I might just answer these verbally. Oh, when you have to construct the bisector, there's a technical way to do that using the compass. So I would Google that, and then if you're still confused, come see me. There's some really good videos about construction of a bisector. Yeah.
You said the C, should I say C for the first question?
So for those of you that I put see me for the first question, that's probably the only reason that you didn't master, or even if I did give you mastery, I wanted to talk to you about that one. If it says construct, you have to show how you did it. You can't just draw an angle and draw what is the bisector. That you have to actually use a compass. So what I was really looking for there is that you would have an angle set up, and then there would be these arcs that met each other, and that's a really bad. There would be these arcs that met each other, that then the line through that, if I could draw anything worthwhile, the line through that point would then be your bisector. Yeah.
What if we don't have a compass?
I have many. So this right back here, you guys are always allowed to borrow these things. I could be in the middle of teaching and you can come in here and borrow these. This cupboard has pretty much anything and everything that you ever need. Compasses, rulers, mirrors, protractors, circle drawing. There's some really cool things that help you draw circles.
Whoa.
So you can put this on your paper and then spin it with whatever size circle you want. It literally does any size circle that you want. There's also this circle drawing tool. This is pretty cool. You can open this and use it if you want. But yeah, my compasses are all sitting back on here.
Okay.
So you can borrow one for a while if you want. Just make sure I get it back, please. We do not have much money to replace them. Other questions? Chapter 1. Ethan.
2 and 3.
2 and 3. Look at 2 and 3 by looking at the alternating terms. So don't look at it as one big long series. Look at the even terms, and then look at the odd terms, and look at the pattern for both of those.
Excuse the interruption. Can I please have Lydia Vandalay to the office? Lydia?
You can correct them again.
Oh, I haven't said anything because
Oh.
I'm scary.
No, tell Miss Cavalucci, the new secretary. Tell her she's really nice. And Miss Warren's really nice too. She just doesn't like. To you guys, she doesn't probably seem as nice, but she is really nice. You just have to get to know her. You guys probably don't have time to get to know her. She likes pigs, like a lot.
I can
Like
tell.
really likes
If
pigs.
you look at her desk, I think you.
Every time she sends out the attendance list, it's always got like pictures of pigs and stuff on it. She put Piglet the other day, like from Winnie the Pooh, and I like emailed back and was like, Piglet, I love Winnie the Pooh. All right, what other questions from the Chapter 1 assessment? You guys just got back.
2 and 3, how would you write that out?
So for 2,
Really, but how would you?
Odd terms.
so what was 2 again? Give me the-
5, 1, 7, 0, 9, negative
Hold on, 5170.
Negative 9, 9, negative 1, 11.
So if I look at my odd terms, what's happening with my odd terms?
Go to 5 2.
Going up by 2. If I look at my even terms,
They're going down by 1.
going down by 1. So that should be able to tell you my next term will be a red term, and the term after that will be a green term. Same thing on number 3. Find what pattern is happening. Even if it's happening in an alternating fashion, there's this pattern happening there and a different pattern. That's okay. There can be multiple patterns in one sequence. Other questions? Rhea.
Can you do 14?
14. Man, I didn't know there'd be this many questions. I should have found the file. Oh, so so it just can't be. I don't want to do it because I want you guys to figure this out. It can't be reflexive because reflexive is when something is equal to itself. So
Excuse this interruption. Could I have Hannah Dolan to the office? Hannah?
how I always hope you guys remember reflexive is think about reflective. I know that what's in my reflection is me because it's me. I know that I am me, right? That's easy. But when it's ABC is equal to DEF and DEF is equal to ABC, that's not the same thing. That's taking the statement and kind of flipping it around. So instead of saying A equals B, I'm now saying B equals A. Or really, B equals E. If we want to talk about the angle names, and then E equals B.
What would you get correct?
I'm gonna answer your question, hopefully by showing this. What property would allow us to do that? This is a property of addition, but there's also properties of equality that work like this. Michelle?
Asymmetric property.
Okay, so, well, that's not exactly this one. This one is commutative, right? I can change the order of addition. That allows me to commute, but now that you just kind of like gave it away. Yeah, so when we talk about commutative property, we're saying this expression is equal to that expression because I'm allowed to change the order in which they're written. But when I talk about what you guys really have is angle B is equal to angle E, and then angle E is equal to angle B. So now why, do you know why that's symmetric?
Because it's kind of like how in symmetry, they look like, it's kind of like a flipped mirror image.
Yeah.
That is kind of a mirror image, except for you can't really flip the letters themselves.
Right. It's symmetric because it's telling you the same thing, but just in a different order. So it is communicating the same exact thing. It's just turning it around. So instead of saying reflexive, because it's not equal to itself, it's just saying the same message in a different manner. So it's the symmetric property of equality. So that one we kind of gave away.
So wait, so first, well, 2 questions actually. So if we're doing like these definitions when we have to name the property, you just don't know the property, how are you supposed to correct that?
Well, correcting it is figuring it out or coming to talk to me. A lot of times that through a conversation, I'll just put a check there. But you can also try to figure out, like I had, I think one person who said it was the commutative property of equality. There really isn't a commutative property of equality, but that's what this is the symmetric property of equality.
And then my second question is, how would we actually show you these corrections per like
Different sheet.
different sheet?
Yeah, use different sheet of paper.
Right, cool.
Sorry, I forgot to say. Always, even if it's like, I mean, if it's like one correction, you could put it in like a box or a different color pencil or different color ink. But if it's a couple things, do it on a different sheet of paper. Help make my life easier, please.
If we got mastery, you don't.
If you got mastery, you're good. But if you have a mastery and a see me, please come see me. I just want to talk to you about something. Yeah, Calvin?
17.
17. Oh, I'm not doing that.
Wait, Mr. Hudson.
Were we supposed
Okay,
to
I'll
make
talk about it. But so if x equals y, and then you're told x equals 18, and then you're told, wait, so it says x equals y, then x equals 18, so then, that's the big key there. Then y equals 18, so you had x equal to y. Then you got told x, and I think it said and, didn't it?
if?
Oh yeah, so if x equals 18, then they tell you y is 18. Now, would I be allowed, based off this, to say that? Can I do, yeah, the property we just talked about, the symmetric property of equality, allows me to flip around an equal statement, and it's still equal. So now, so I was allowed to flip that around, it's the same thing. But now, I'm using this instead of that because of this. There's a property where if I started, and I don't want you to give it away, but if I started with one thing and replace it with another thing because of a statement that I was told, all I really did was this value in for the other value.
Got it.
Okay. All I did was this value in for the other value. Any other questions? Chapter 1. Chapter 2, I actually have the
I have a
file.
question.
Yeah?
We're supposed to do question 21. Because it.
Sorry, now anytime you guys say 21, there's a
I know.
Yeah.
Please.
Yeah, you were. So,
no,
You told
wait.
us,
For-
yeah, you
you
didn't
said
tell
not
us we
to
didn't
worry
have to.
about it. Yeah.
well, so then I reread it, like when I was at home. Most of you did do it. So if you did it, awesome. If not, I'll just kind of give it to you.
Okay. Thank you.
Starting two sequences with the same picture. When somebody had asked it, and I thought they meant start a sequence with the same two pictures. That doesn't make any sense. But I had misunderstood what you were asking. It tells you to start two sequences with the same pictures. Then make them have a different pattern. Yeah.
You have to start them with the same 2 pictures.
Yeah, the same, like both of the pictures. Or if you want the same 2 pictures, we can still do this if you read it like that, but some people read it differently than others. So I accept it either way. But I could then just kind of keep this pattern going, right? And then here, if I do this, I could then keep my pattern going. So it's a pretty simple, sorry, that's supposed to be a triangle and it doesn't.
Okay.
Yeah. But all it's trying to show is that even if I start with the same 2 initial terms, I do not have to have the same pattern. I can have 2 different patterns even if I start with the same 2 initial terms. All right. Anything else? Chapter 1. Chapter 2. Anything from the front? Because I kind of doubt there is. Anything from the front? Yeah. 3. So FG is in the plane of the top of the prism. So lines that are skewed to it need to be in a different plane. So if you chose HI is actually parallel to FG, and they're in the same plane. I'm pretty sure I let these go if you did like a GI or an FH. But the easiest way to go is choose something that's in like a different plane and not going to interact with it. So the easiest lines to choose would be like an MI line. That's totally skew. It's on a different plane and it will never ever touch the FG. Or like MK, that's in a different plane going a different direction than FG. Now LM would be dangerous if you chose LM Because what relationship could LM have to FG? What relationship should it have? They're parallel. So you can't really choose any of these lines. None of those would work because they're all parallel to FG. Does that make more sense, Ethan?
I said FJ and GK.
FJ perpendicular to it because it's in a separate plane and intersecting. So because one's in the vertical plane and one's in the horizontal plane, so regardless of the the turn of this line, they will be perpendicular. So no matter what direction this arm points, it's still perpendicular to my other arm. That's the thing. Is it's always going to be perpendicular. So you want to choose the one that doesn't touch it. What's the other one that you had chosen?
GK.
GK, same thing. Yeah, they're perpendicular because they intersect. Now you could choose MI and FG, and because they don't intersect, then they don't necessarily have to be perpendicular. But I would still yeah, I mean, you could get away with that one.
Remember the planes, one's flying this way, and then another one's flying lower than this way.
Or the
And I
highway.
Yeah.
I remember that.
They don't intersect.
All right, other from the front. Other questions from the front. Going once. Going twice. Sold. On the back. When you have to construct, and all this tells me is these have to be parallel, and then Wx is f, and Yz is 3f. So this uses construction.
You gotta do 3 times.
You gotta do 3 times your f. So however big your f is, so let's say I here construct math tools. We open this up.
Smart one comes with that?
Yep.
Sick.
I wanted to clear the ink, not clear my compass. So, right now, I can create f. And then I would need a point right here. So there's a distance of f. Now, if I want to create a 2f, I could just do this, and that's now 2f wide. And if I flip this and put it on this edge, from this edge to this edge is now 3f wide. And then you just have to show that my lines are parallel, and you're done. But you have to show, it has to be constructed. You can't just draw it and say it. If it says construct, it's looking for you to construct.
How would you make it how would you make it parallel?
In Math 1, we covered how we know that 2 lines are parallel. So if you need to review that, you might need to review that. Because remember, so my hint to get you started on this, if I have a line that goes through these, it's straight through 3 points, it's a straight line, right? If you have 3 points on a line, it's a straight line. So to create a parallel line to it, let's go to red. If I start on this line and open up a gap, what's hard is it's going to draw as soon as so let's say I make a smaller gap. No, I'll go bigger gap. At the top of that arc, then if I move over, still on my bottom line, at the top of that arc, there's a point at the top and a point at the top. If you draw a straight line through them, that should be parallel.
That's not how you did it in Math 1.
There's multiple ways.
It's like a parallel thing.
You're talking about parallel with a transversal. So if I first drew my transversal, then I can do it differently. But this is, if I don't have a transversal, this is one way that we can do
It's
it.
just like making it from scratch.
Yep.
Alright.
All right. Other questions from chapter 2? You also have to show the construction. So those arcs at the top There's 2 arcs at the top, 2 arcs at the bottom. Then your line goes through both of them. Anything else? I had some question marks on these problems. Ethan? 14. How are same side interior and same side interior and alternate interior theorems alike? So a nice way that we could set this up. So same side interior like those, right? So you can talk about what relationship those would then have with each other. And then alternate interior, if I draw this and this, that's a set of alternate interior. And those have a specific relationship also. So it's comparing and contrasting what relationship do they have with each other. How they're similar, well, they're both inside the parallel lines they're referring to. So these could be for blue. Like my green ones are obviously for red. They're interior for my red lines. But my black interior, those could be for the blue or for the red because they really relate both of them. So think about what relationship would these green angles have? What relationship would these black angles have? If you can't figure it out, come see me. Okay. 16. So we know the parallel postulate. Oh, I love this problem. I told you guys this was a famous one. Too zoomed. So if I have a triangle, ABC. Cool with that? Mm-hmm. I have my red line there, say line L, and line B. L's parallel to B. Now this is a really, really famous problem based off the fact that I can draw a parallel line. I can construct a line parallel to any other line. Like we could have grabbed our compass, set the distance here from the base up to this point, and then made an arc there, made an arc somewhere else, and connected that. I can construct this line. Right now, we are willing to accept that it is parallel because we know that we could construct it. So now, what most people then get goofed up on is you need to imagine.
Is it though?
I think it is. It's totally you. It's okay. Just silence it. Here, you want to make them awkward? Who is it?
Oh yeah, just go.
Oh, I wanted to answer it. I could have made them really awkward.
I don't even know this.
I know. That's why I would have answered it for you.
Hello.
Excuse me, Michelle Saeed's phone. How can I help you? Yeah, no, she's in school right now. She can't come to the phone. Thanks. Call back.
I didn't even know who that is.
So,
No, it was a Dyer family.
so let's. Well, yeah, but if she didn't know the number, if this line were to be extended, and this line were to be extended, or if that line were to be extended, and that line were to be extended, we need to start finding some angle relationships. Now, what I can't use right now is the statement that A, B, and C equal 180. Because I don't know that. We're trying to prove it. So if on your paper you then stated triangle, like angle A plus angle B plus angle C equals 180, like you can't use that. You're trying to prove it. Now, what could I say about any, like, I need to start identifying or adding in some pieces and parts that I can relate to each other. Michelle?
You can use the exterior angle that's supplementary to B. That's like.
So the exterior angle that's supplementary to B, so that would take this whole angle then, right?
opposite interior angles are equal to the exterior.
Yeah, but that is derived from the triangle angle sum theorem. So I let you get away with that on your paper, but we shouldn't actually use that since it uses triangle angle sum theorem to make that postulate or that theorem. So we could, but that's using some.
Use that on my paper though.
Well, somebody did.
I don't think
I forget sometimes when you guys do these things. What if, for a second, we forget that this line exists? What if for a moment we forget that this line exists, and all I really have is this line and these lines? Is there an angle relationship that I can create? Can I give something a name? Like, does angle C, because angle C is at the junction of the lines that I care about, does angle C relate to anything else? Calvin?
Angle C, I'm pretty sure is congruent to, I don't know what to call it. The angle to the right of angle B.
So this angle, we'll call that D. Why? Why can angle C be equal to angle D?
Because, alternate interior angles between parallel lines.
They're alternate interior angles. So C is equal to D, and D looks like it's on a linear kind of trio with B. If I then forget about my yellow line, do you see where I'm headed here?
Yes.
I think so.
Oh,
Carmen.
Then we're gonna call it E is congruent to A
Why?
because of the
Alternate interior angles. And then, what do I know about EBD?
linear pair.
Well, linear trio, but yes,
Equal 180.
they are supplementary because they form a line. And because E is C and D is C and E is A, based off substitution, we've now proven the triangle angle sum theorem.
We've proven it, Caleb.
Jeremiah, is it something quick?
Yeah, it's like, he's like, they did. Look, the math
This is review for the test.
try it up.
So you're going to see some things be repeated. Means they're really
That sounds like
important. So that also might clue you into something that would be on the test. That's kind of like, hey, make sure you understand this really well. All right, are we cool on this one?
Yeah.
Really famous. I've been told that you are asked to solve that on like the ACT or SAT or like some of those tests, like the big tests. So make sure that you're familiar with this. The big thing is being able to get your brain to block out the parts that you don't need. Until we highlighted things, it was difficult to see the alternate interior angle pairs. But once you do like just pick and choose what you look at, it gets simpler to figure out. Calvin?
I saw it, but I didn't know where to go from it because I
Yeah.
was just looking at the right side.
Yeah, it's a little difficult. Sometimes it's easy if you like lay a piece of paper over what you're working on and only draw what you want to look at for the moment. Like you can trace things. That sometimes helps.
So you just want us to like rewrite basically what we just did up there on another piece of paper?
Yeah, but in a way that makes in a way that lists out.
So
why.
like basically like the angle equals yada.
Yeah, I like 2-column proofs. Some people like hate proofs just because they're proofs, but I love 2-column proofs because there's like, here's what I'm telling you and here's why I can tell you that, and now here's what I'm telling you and why I can tell you that, and it's just very, very process based. Yeah.
Is number 13 just like number 12? Like, but for perpendicular line?
Yeah.
Okay.
So if you draw a line, then you should end up with an arc up here and an arc up there
Yeah.
and an arc down here and an arc down here, and when you connect them, yeah. And you're gonna have points on the line, obviously. All right, we are not going to get as far as I assumed we would today, but that is totally fine. Assuming that I can find our notes. I set them somewhere.
Mr. Hudson, are you growing sideburns?
Me? No, I just need to get a haircut.
Oh, it's really weird.
Thanks for pointing that out, though. Tells me that I really need to get a haircut.
Same. Or that Scarlet, notices that.
No, they are pretty out of control right now. I'm going for the
You
Wolverine.
see out of control? My brother looks like a
There was a
monkey.
counselor at a camp when I was serious.
Yeah.
Big mutton chops?
Yeah.
Yeah. So, notice, because I wanted, honestly, my job of copying to be easier, I made this a packet. The rest of the stuff should be coming from the copy center, but the link to get to the copy center hasn't been working lately, so kind of awkward. We might as well just keep going with the same recording. Brian, if you've been watching this whole time, good for you.
Hi, Brian.
Love you.
All right,
I do.
so we have...
Oh, I forgot Brian was here.
Excuse the interruption. Could I have Lainey Reynolds to the office? Lainey?
We have like 13 minutes left to discuss some properties of parallelograms, and I was planning to do 2 lessons today. Now that we did the test review, it's totally fine that we're not going to, but this 5.2 should be a little quicker. So that's why I had not put 5.2 and 5.3 on today. I just kind of assumed that we wouldn't actually get there, but my plan, my hopeful plan had been that we would. So, what do we know about parallelograms? Like, don't even look up these theorems, just what do we know? Like, we've been working with these for a while. A parallelogram is really a set of 2 parallel lines.
Oh, you stole it, mine.
Like, okay, it's in the name, parallelogram. But because it's just sets of parallel lines, there's all these special relationships that get made. This actually refers back to the alternate interior angles or same side interior angles, those sorts of rules. Caleb?
Well, I'm going to use one of the pictures right there because it makes
Yeah.
it easier for me to list stuff. Like if you see A, B, C, and D, angles C and D are going to equal 180 because they're same side interior angles.
So our same sides are going to be, what do we call that? Supplements.
That's what I was thinking. Totally.
So C and D or C and B. And since C could match with B, or B could match with D, or C could match with D, then we can also say, what other, we see supplementary relationships. What other relationships do we see? Not only supplementary, but, wait, what? Not complementary.
See, that's why I yawned.
Congruent, which ones would be congruent?
Diagonal opposites.
So B would be congruent with D, A would be congruent with C, because we know that they are both supplementary to angle C, therefore substitution can show me that they are congruent to each other. So here's our supplementary rule. Here's our congruent rule, everything that we've essentially just stated out. And then our diagonals. This is where it gets really cool. In a parallelogram, the diagonals bisect each other. So we have a short diagonal and a long diagonal, but they both bisect each other. So then, if I know any of these lengths, I can start to find some really cool relationships. I also see congruent triangles created in there. I can prove because side, angle, side. We have vertical angles that I could prove congruent triangles. And our last one here, essentially we have 3 parallel lines and 2 different transversals. Obviously those transversals are not congruent, but this kind of falls under the parallelogram rules because it's a rule about parallel systems. If I know BD, they say it the other way around, then that's going to be congruent to DF if I've seen any other congruence relationship. So that is because this gap right here, AC, is equal to this gap right here, CE. We're told that. So that means that preserved congruence will be the same on the other transversal. And that will come back into play with our homework. So we're going to run through this pretty darn quick because I have 8 minutes left. In PQRS, we're looking for the measure of angle P. Now, we are given that angle S equals 64. If you can't see where that arrow is pointing, S equals 64. So what relationship would S and P have if they are on the same side of the parallelogram? Ethan?
They're supplementary.
They're supplementary, so this supplement to 64 would measure
116.
116 degrees. Now, the order of the parallelogram, we don't even need a picture. I mean, it says, suppose you adjust the lamp. But even if we didn't have a picture, S and R. Well, if I look at S and R, they're right next to each other in the order of the parallelogram. So, would they be supplementary or would they be congruent? Supplementary, because they're neighbors. If they're across from each other, they'd be congruent. So if it was S and Q, then they'd be congruent. But if S and R are supplementary, and now S is 86, what's
104.
R? There you go, 104.
I was preparing for it.
Wait, it's not 104.
94.
It's 94.
I said that.
Ah,
I said
that's what happens when you work too quick. And of course, it still took the picture. That's also what happens when I trust people.
Which is why you should never trust
Never trust David.
What?
Yeah, like
Caleb, like you're one to be talking.
Hey. I mean,
Right.
it's kind of true. But
94. Good catch.
That's true.
It's also why you should never be trying to work fast. Like when fast is your priority instead of accuracy, that's very, very dangerous.
yeah, no science.
So, we're not going to review much of this. So this goes through proving why my opposite angles, or like across from each other angles, are congruent. So if you want to read through the proof, it's pretty straightforward. You have consecutive angles, which prove to be supplementary. And yeah, then we go from there. So, because we're running through this very fast, we need to use this diagram at the right, where we see that ABCD is a parallelogram inside of triangle AKM. We're also told that AK is congruent to MK. So what kind of triangle is this if AK is congruent to MK? Isosceles, right? And that's all we know. So we need to prove that BCD, we're trying to prove that this angle is congruent to CMD. That angle. Where should we start?
I don't know.
So something that we've already identified was we have an isosceles triangle.
Caleb.
Caleb?
Well, actually, I have another way of doing it. Well, I guess it kind of refers to isosceles.
Okay.
Since it's isosceles, you know that angle M is congruent with angle A.
So we could start by saying angle M is congruent to angle K, and both of those are specific enough we can name them with just the individual point. Because, why?
Isosceles.
Yeah, because the AK is congruent to MK.
Do you mean it's congruent to angle A?
Is congruent to A.
Yeah.
Alright.
My bad. M is congruent to A. Wrote the wrong thing. Because these are my two base angles, and they are opposite of the two sides that we know are congruent, since they're in the same triangle, opposite to congruent sides. So then, next thing we do, Caleb?
Well, since you know that the diagonals of a parallelogram, parallelogram, I think it's supposed to, yeah. So, okay. Since you know the opposites are congruent, you can tell by A is congruent to C, therefore making C congruent to M, and then, that stuff.
Oh yeah.
Okay, so we're going to say A is congruent to C. Or are you saying C is, which, I mean,
A
order, I
is
guess.
congruent to C.
So A is congruent to C
So M is congruent.
because,
Because, wait,
A is
because the,
congruent.
whatever, I don't, well, because they're both supplementary to D. If you, wait, yeah.
Okay. So, I mean, there's many
Probably an easier way to
reasons.
say it, but that's just how I
Yeah.
remember it.
Because both are supplement to angle D.
Yeah.
Sure. There's a lot of ways that we can, refer to that.
And then the final
And of course, that D is really ADC. We should probably name that with a three-point name because D is two different angles. And then what do we do to get to our final? Substitution. So then we can say angle C is equal to angle M from substitution. Questions?
Is it right?
Yeah, it's just not capturing. Especially since I know Brian's not here. There we go. So try this on your own for a minute. I'm given 3y minus 7, 2x, y, and x plus 1. I want to know who figures out the method to solve this. The most efficient method to solve this.
Okay.
Try this for a minute or so. There's a very efficient way to solve this spring out of a pencil. Because my diagonals bisect each other,
Yes.
there's a very specific way we can apply that. Anyone tell me what we should do? We're running out of time. That's the reason I wish I could give more time. Calvin?
Set up a system of equations.
That's actually a harder method to solve it.
Oh no. I already did it.
Well, okay, depending on how deep you're thinking about going with that. So what was the next thing that you did? So if you set up two different equations,
And then y is equal to x plus 1, so you substitute x plus 1 in for y.
because y is equal to x plus 1, I can really just initially set up that 2x is equal to 3, sub in the x plus 1 for the y, minus 7, and then we only have one variable, and we can just straight solve it from there. I can then, once I know the value of x, find the value of y, and then we're done.
Do we need to give the answer or?
No, we may pick up this at the beginning of class tomorrow just to finish it and then move into 5.3. But you have your 5.2 homework. You are more than capable of doing probably at least 90% of that. So we will pick this up tomorrow to finish. But 5.2 is the only thing you have for homework. So thank you guys very much.